So here we have array1, bigger2. It's saying start with two integer arrays, okay? A and B, each length 2. So we know the length is 2. And the length, we know that the length of the array is just the number of boxes that we have. So if it says length 3, then there are 3 boxes. And of course, if it says length 2, then there are 2 boxes. Now, the thing with this is that although we have our boxes, we also have indexes, which are essentially references to the boxes themselves, which contain an element within the box. And so what this is essentially saying is that we have 2 arrays. One is A, and we have another array, which is B. And of course, this is also length 2. And oops. And this has, essentially, it has its own set of indexes, 0 and 1. And of course, these reference the boxes. And so it's saying, well, these boxes, these can have elements. And these elements are just arbitrary values. And what you want to do is you want to have, you want to essentially have these 2 different variables which actually add the elements in both boxes. So the box for A, or the sum A variable that we're going to assume that we'll have, is essentially going to keep track of the sum of all the elements in the A array. And so this would be 5, whereas if we had another variable called sum B, that would be 7, because again, we're adding all the elements in the array. And then what it says is, it says, well, return the array which has the largest sum. In the event of a tie, return A. So we want to return the array which has the largest sum. So if A has the largest sum, in other words, if sum A is greater than sum B, we'll just return A. But of course, if sum A is less than sum B, then we'll just return B. So we're just returning the largest array. But of course, if they're both tied, then we'll return A. And so how we actually add these elements is, so if I had int sum A, I want to store the addition of both of these values, which would be, I would reference the array and I would reference the index. And so this would say, okay, we're looking at the A array, 0th index. What's at the 0th index? Well, element 2. Plus, again, reference the same array and the first index, which is of course the second box, because the count for the index starts from 0. Then we reference the second, and it says, what's there? Well, it's 3, and so 3. And so it adds both of them up, and then of course we get 5 here. Same thing for B. So let's actually code this, right? So we'll have int sum A, right? We'll set those equal to 0, and we'll have int sum B, and we'll set that equal to 0 as well. And then we'll say, okay, well, sum A is actually just A plus, and we can do this because we know the length, A plus A in the first index, and then we have sum B, which is of course just it's the same thing as A, but this time we're doing it with B of 1. And we'll just say, well, if sum A is greater than sum B, then we will essentially just return A in that case. Otherwise, if sum B is essentially greater than sum A, then we will return what is larger. But of course, there's that caveat there that says if otherwise, well, okay, so you could just sort of say, okay, if sum B is equal to sum A, then return A. And I mean, you'd get a favorable result, right? I mean, if we were to run this, it says missing return statement. Yeah, it looks like I have to actually return something here. 1 second. Yeah, so you could hard code it and say, yeah, if sum A equals sum B. But really what I want to stress on here is that if you think about it, right, if sum A is greater than sum B, and we've also taken into account if sum B is greater than sum A, the only possible eventuality is that they're both equal to each other, because they can either be equal to, less than, or greater than, right? Those are the only three possibilities. So the else is really a catch-all there. Now, for instance, if we had this would essentially say, okay, if sum A is greater than sum B, return A. Otherwise, and what does this otherwise mean? This otherwise means it can either be greater than, or it could, or sorry, less than, because that's not what's specified here, or it could be equal than. And so we don't really have to specify that at the end there for the equal. This was, of course, one way to do it. Now, if you were really to be like a weirdo or something, you could do it this way, where you have you actually iterate through the array itself. And okay, since they're both the same length, you can do this. And you can say, okay, well, I'm going to use an accumulator pattern for sum A, and sum A will essentially be what sum A was before, plus the current element accessed by the current index. And then, of course, you can do the same thing for sum B, and then, of course, access the current element at that index. And so you could do that, right? And that would work. And then after it's all said and done, just compare sum A to sum B. And if of course it's greater, then return A. Otherwise, in the event that the sum B is greater than sum A, return B. Else, of course, a catch-all, return A. And it said array required but int found on line 9. Line 9. So this is line 9. And so it's saying array required but int found. Let's see. Sum A plus sum A is equal to, yeah, you actually have to reference the array in this case, not how you access these elements is you preface by the name of the array itself. And so that's what we were doing wrong there, but that's really how you do that. So